So, hey everyone, uh, I'll get started to talk about chaos engineering. Sayan introduced himself. Again, I'm working as a community manager at Harness, and I'm also a CNCF ambassador, and I've been organizing a few events in the community, KCD, Bangalore, Chennai, chaos engineering meetups we are doing, and you can connect with me on the socials. And Sayan is a senior software engineer too at Harness. He's been maintaining Litmus for some time now, and you can connect with him on these socials once again. And today we'll be talking about what is chaos engineering, why chaos engineering. We'll also introduce the open source project Litmus Chaos to you all, and then we'll also talk about, how you can run a chaos engineering demo. So we'll move to that, which will be run by Sayan. So let's talk about the need for chaos engineering first. I mean, we've heard about this topic a lot, but why is it crucial? Why is it important? Why we believe that chaos engineering is one of the solutions to achieve reliability. And as you can see on my screen, there are a few examples of outages that we have taken. I mean, if I have to take a real life example, then let's assume there's a Black Friday sale that's going on, and the demand or the demand on the website itself has an impact. The systems go down. There's a possible outage, and there's companies losing in millions of dollars just because of a particular outage or just because of unpreparedness for that outage. And outages are expensive. You can see we have taken some examples: Wells Fargo, British Airways, Slack, and it leads to a lot of impact, loss in customer confidence, loss in reputation. There's a financial impact. There's loss in obviously employee confidence as well. And other than that, the need of the hour itself has, I mean, reliability, although it hasn't been seen as a goal of DevOps, but the need of the hour itself is to focus on reliability itself, because outages can happen anytime your systems can go down, anytime something can go wrong. And with applications becoming more dynamic, more cloud native, the shift, the paradigm shift itself calls for uh, extra attention or care on reliability as a DevOps aspect. And moving ahead, I mean, outages are still happening. There are downtimes. There's operation costs are increasing, and companies are experiencing frequent outages. I mean, and why to wait for an outage to happen? Why to wait for your system to go down for a downtime? Or why to wait until you actually are able to deal with the repercussions of this damage in terms of finance or reputation? Why not identify what's going wrong? Why not cut down on those operation costs? Why not, I mean, instead of investing on more team members or quality, why not find something that can help you identify or meet your reliability goals, meet your objectives, and make things better in terms of reliability as an aspect. I'm talking a lot about reliability here, and that is how we'll introduce chaos to you in a little while. But if you choose not to decide, then you have already made a choice, right? Because if you are not acting upon it, if you're not inducing a mechanism or inducing something which will help you make your systems more resilient, then in a way you are deciding to not act on it, and you're deciding to incur that damage that these outages can have. And that is why, I mean, before we just introduced chaos, is reliability a goal in DevOps? So usually it was not seen as a goal in DevOps, and we have given a lot of emphasis on speed, quality, and developer productivity, where applications are being delivered fast. There's code is being shipped fast, and there's a huge need of being dynamic in nature. The code quality needs to be maintained. There are so many new products and projects out there that are being introduced, and developers are fighting amongst each other to bring in new technologies itself. But there is obviously the overall goal to maintain speed, quality, and developer productivity involves ensuring reliability and not compromising on reliability itself. And the obvious questions are: reliability of what, reliability against what, and how can we measure it? So obviously businesses, I mean obviously the enterprises itself, they are we see a huge shift. People are moving from monoliths to microservices. There's huge adoption of Kubernetes, and there's obviously the idea is to uh, ensure that these business services are reliable, and ensure that there are some amount of steady state checks that are happening. You identify how your systems are behaving during the steady state, and then you obviously differ it from your normal behavior when there's a chaotic condition that is happening. And that is how we introduce chaos engineering to you, or the idea of chaos came up to ensure reliability. And chaos engineering is nothing but introducing a fault to the steady state of the system, or to introduce a fault to the system to identify what can go wrong if that kind of a condition or those scenarios happen in real life. What kind of disruptions may happen when there's a chaotic scenario actually happening when your systems are in production. And that is why it differs from all the methodologies out there in terms of testing, where you are actually identifying the steady state of your system. You're introducing a fault. You're constantly going through steady state checks, and you're ensuring that are your systems resilient or no, are your systems reliable or not, in spite of that kind of a scenario or that kind of a fault happening in real life. And why is it a solution? Why is chaos engineering a solution? Why is introducing a chaos scenario a solution? Is because obviously it's collaborative in nature. There's a myth that it's only for the SREs, but it's not just for the SREs. It's, I mean, today being a part of the community for so long, it's also for the developer persona, people who are in QA testing, who are just trying to bring in some, let's say you're trying to create some changes or bring in some new developer applications. Chaos engineering comes into play there. The idea of introducing chaos experiments, inducing a fault, that comes into play. And chaos engineering is robust. I mean, you can have your own experiments, you can write your own experiments, or you can introduce experiments that are already out there. In terms of, let's say, a very simple experiment that I'll talk about in terms of Kubernetes is a pod delete experiment. So I mean, these experiments help you identify what is the minimal I mean requirement your systems have, or what you can do in terms of improving system resiliency, how you can integrate it into your CI/CD of the systems. I mean, if you talk about the typical practice, then chaos engineering was seen as just production level failures, where Netflix introduced this concept of bringing in just the spot failures and bringing in the chaos monkey tool, and then it changed to the Symbian army, where there was just, I mean, platform level failures that I mean, for multiple scenarios. But then chaos engineering today has changed a lot, where there's application level chaos, where there's infrastructure level chaos, where you have the ability to induce chaos experiments or chaos engineering scenarios into all parts of your system, or in each phases, from your I mean build phase to your test phase. You can find weaknesses. And then observability, obviously that's important. You identify metrics, and then you use them to assess your SLOs, SLIs. How can you build confidence in your systems? How can you make your systems more resilient and reliable moving ahead? So how do you introduce chaos, or what's the best way, or the most potential way of introducing chaos? Obviously, you first identify the steady state of your system, as I spoke about, how your systems are behaving during the steady state. What's I mean, the system like when it's showing its normal behavior. And then you create an experimental group. You run a set of chaos experiments on your target system. I mean, these scenarios can be run in series altogether, or parallelly, or you can run a single experiment. A scenario is nothing but multiple chaos experiments run in series or parallel according to the requirement of the system or identification, which is done according to the SLOs. Basically, an SRE identifies them. Or while you are running a game day, a chaos game day, you identify how do you want your system to behave, or how does the system behave when a particular outage happens. So you run these scenarios, and then you observe them. what are the results that you're getting, how does your system behave, what is the normal state behavior, and what is the behavior with the experimental group. And then you minimize or your blast radius, and or you tune in your blast radius, and then you use these learnings to improve your reliability again and again. So this system, I mean, this overall loop goes on because reliability is something you need to continuously achieve. So there's uh, chaos engineering helps you achieve continuous resiliency, basically, where you are continuously testing your systems again and again by identifying the system and inducing your faults. So as I mentioned again, yeah, this is just uh, depicting what we just spoke about. You identify the steady state conditions, you introduce the faults. Are your SLOs, service level objectives, continuing to be met? If yes, then your systems are resilient. If no, then there's a weakness, and then you go back to fix the weakness. You identify what can be done better, and then you again go through the loop again where you introduce the fault and continuously test your systems. So how is chaos engineering typically done? It was, I mean, seen as a practice for the SREs. Again, these are myths that we are speaking about. There was just game days that were being introduced where there were a set of experiments that were run, and then the experiments were run according to how you identify your systems, and there wasn't uh, beyond that, it wasn't done. The experiments were not automated. It wasn't seen as something that can be integrated into the CI/CD of your systems, and observability measures were not there. It was seen more as a commodity and not as something that you usually need. And that's why, and not just with Litmus, I think chaos engineering has changed today, where it was seen as a luxury, and it was seen as something which is not really necessary. A lot of communities and enterprises were not focusing on it. Today, the focus or the transition has changed, and we have moved on to changing the way chaos is done, where now it's integrated into the CI/CD of your system. There's so much more that can be done with chaos, observability, and logging, monitoring. Everything has changed completely, where each and every system behavior, I mean, is being monitored, is being analyzed. And today, not just SREs, even developers, as I spoke about, are practicing chaos engineering. And with this, we meet Litmus Chaos. It's an open source chaos engineering project. It's a CNCF project. And the idea again with Litmus was to, initially it was just for Kubernetes, where we started with Kubernetes level chaos, and then today it is enabling teams to identify weaknesses in and potential outages in systems beyond Kubernetes, in the DevOps pipelines. And beyond that, if you are using, let's say, it's I mean, enabling cross cloud chaos engineering applications. So it's driven by cloud native innovation. So with the community moving on to cloud native practices, and so many the adoption of so many new aspects itself, Litmus is trying to meet that, where you can derive application level chaos. You can write your own chaos experiments. There's a chaos for the cloud. There's VMware chaos, and there's so much more that you can write using the Litmus SDK. And the SDK is nothing but it helps you write your own experiments, and you can use it with Litmus. I think Sayan will be talking more about it, but it's a CNCF incubating project. Again, it has been in 5 years of active development. It's been adopted by the community out there. There's a milestone of 15 million Docker pulls that we achieved a couple of weeks ago. And then the chaos experiments out there, from Kubernetes level, as I spoke about, to cloud native experiments, to application level experiments. There's so much more you can do with it. And then there's a 3.0 version that with an improved UI that comes out soon, which will help you induce chaos in a better way, manage multiple chaos scenarios, and do much more for your chaos engineering needs. So this is about Litmus. And I think though this is just a stat that how many people are, where all we have seen Litmus being used. I think we used the stat few days ago. And then yeah, that's about the project. And today it's being used by a major set of backgrounds or users. Let's say from the banking sector, e-commerce sector, you talk about I mean food delivery applications, anything that's out there is focusing on chaos engineering itself as a practice, and that is what we have identified as a community. So I think moving on, we'll be talking about the architecture and more, which will be covered by Sayan. So I'll allow Sayan to take over from here, and I'll stop sharing, and then we can take questions in the end.
Okay, Prithvi, can we take few questions and then San can do the demo? Just one or two questions.
Okay.
So yeah, a few people they have pinged me these questions, and anyone, if you have any questions, please raise your hand. I will unmute you, or you can post your question in the chat. So one of the most pressing question or one of the most asked question is how to get started with chaos engineering. Like you already mentioned, the Litmus Chaos project is one, but anyone who is beginner or who is new to this field, how to get started?
So I think it's about understanding the practice first. Where do you need chaos? How do you need chaos? And I think chaos as a requirement, as I spoke about, comes anywhere. So while even as a developer, while you're developing, if you understand that these are the possible faults that can happen, this is how I can test the systems, and just starting off with the cultural aspect of it is very important. And then slowly you can develop the practice where there are so many open source tools out there. Litmus is one of them. There's chaos mesh, there's chaos toolkit, or there's chaos monkey, and there are many more tools and out there which can just help you induce a basic fault, or just identifying you can run some chaos tests in your dev environment, in your pre-prod environment. That's the easiest way to get started. And once you start developing confidence, once you believe that you have had some idea of what chaos is, there are a lot of I mean resources out there that help you learn chaos. There's a principle of chaos engineering org that just helps you understand. There are so many resources, and then once you develop confidence, you move on to running it as a game day, and then maybe bringing it as a practice into production. So that's what I believe is the best way to get started. And obviously some community helps you. So these open source communities obviously help you in terms of both resources and getting an idea of what chaos engineering is and how it can help you.
Okay, sure. Thanks, Prithvi. Two more questions. Yeah, or if anyone else has any question, please raise your hand. This is again a big question, like what mechanism will we have in place to quickly roll back any chaos experiment if things goes south? I mean, let's say we started a chaos experiment and it caused a downtime. Is there any way chaos can help us to roll back the changes or to revert those changes? Or I mean, it's not exactly revert, but let's say I started shutting down 10 servers. Can we stop the experiment in the middle just to prevent any outage or anything?
I think Zain, if you
Yeah,
can.
sure. I can take that. So yes, we do have the option of reverting a chaos, and it's like, let's say you also have something like a stop condition, and that is basically like, let's say you are inducing a chaos and you hit a fault, that you hit that specific condition, that maybe your blast radius is going out of reach, or maybe some specific custom condition. Then we have something called stop on failure, which you can turn on, and that would like exactly stop it where the condition is hitting and going off overboard, and then roll everything back. And let's say you don't have any such conditions, or your chaos is going fine, but what you want to do is, once all the chaos execution has been finished, you want to gracefully clean and roll back all the extra metadata and stuff that was created as a part of this, like let's say some of the things that the tools might generate, those things, as well as some of the experiment results and stuff like that. So we have a condition called revert chaos, which if you enable after the chaos is finished, it will gracefully clean up all the extra stuff from your cluster. So that ensures that whatever condition you started it with, you end up with the same thing. Like that is if you opt for it to be that way. If you want to, let's say, retain the logs and stuff, then you can of course turn it off. And once the chaos finishes, you'll still have those resources.
Okay, sure. Got it. I mean, maybe these kind of a things will be clear when you show us the
Yeah,
demo.
correct.
One last question. So, I mean, is chaos is like help us to do any, like for example, we find it out that our system has these issues. So does chaos gives any kind of a recommendation, like any chaos tool, or it's just, I mean, we itself as a user need to figure it out, all those things?
So I think there are a lot of recommendations that a tool can give, but that's, I think, a very tool specific question. But I think while you're running chaos, I mean, the findings that you get that really help you analyze your system behavior. And once the chaos is done, there's a resilience score that you can identify, there's resilience coverage that you can identify, that so that helps you. And then there are probes that help you, induce health checks. So I think, I mean, this is all that we have done, not just specific with Litmus, but I see that these are the functionalities that all the chaos tools out there are trying to identify and bring in as a functionality or practice. And I think these findings help you understand your system behavior better. But I cannot really point out a specific tool out there which obviously has this. But yeah, maybe Sayan, if you to
Yeah.
add something here.
So there are with the Litmus tool, we have integrations with Prometheus and Grafana by built in by default. So using that, you can of course monitor and analyze as to what went wrong where. If you're not, let's say, opting in for that, we have this chaos result CR embedded into your chaos experiment. So whenever you run these kind of scenarios, by the end you'll get like a generated long list of metadata, what went wrong, or what was the passing percent, filling percent, which specific area failed. So that will give you like a clear hint of which area went wrong or what went wrong in that sense. We won't generally like give you a recommendation because it's kind of specific to your individual applications. So we rather not give a generalized solution. So rather than we show like we pinpoint where exactly it broke so that you can take better care of it.
Okay. Yeah. Thanks, Prithvi and Sayan. Anyone else has any question before Sayan can start the demo? Okay. I have a bunch of other questions, but Sayan, first we will start with the demo and then.
Sure, definitely. Let me share my screen. Yeah. All right. So before we jump in straight to the demo, I'll just give you an architecture overview of this entire how it works, how the chaos injection, and what are the important CRs that we use so that we get a clear idea when we do the chaos injection. So on the left, you see the generalized architectural, not a deep dive, but a generalized approach, which is easier for everybody to understand. So we have three main CRs. One is the main one is the chaos engine. The second is the chaos experiment, and the third is the chaos result. So talking about experiment, chaos experiment is something which is like a template or a blueprint, or like a general blueprint of the entire experiment that the fault that you want to induce. Let's say a pod delete. So chaos experiment for pod delete would be like a template for that pod delete that we are going to pull in and then we are going to inject. Chaos engine is nothing but like the part where you tune the areas of the pod delete. Let's say how long you want it to run, which pods you want to target, or what is the specific app metadata, the namespace, labels, etc. Stuff like that. So you can do those kind of tunings in Chaos Engine. And then the third is the Chaos result, which is where when we do the Chaos injection, after a certain, let's say, a few seconds, a few minutes, whatever result we get back is stored in Chaos result. So this is where you'll get like the probe configuration, resilience score, the verdict of the experiment, things like that. So in the middle, you see something called as chaos operator, chaos monitor. This the chaos operator is like the heart of everything because it's like the main operator which is controlling everything in the background. It's not something you can like write out there in the for the users to configure and tune. But it's like something which checks the policy, if checks if the application you're targeting is actually present in the cluster or not. It also spins up, let's say everything is right, it spins up a bunch of it spins up a chaos runner which spins up a bunch of chaos jobs. So what that does is, let's say you execute a chaos pod delete chaos. So chaos runner would be responsible for executing this pod delete runner, and that runner would let's say you have given a time of 60 seconds for the pod delete chaos to happen. So the runner would spin up multiple jobs in that between based on the interval you've chosen. So let's say you want to do 3 pod deletes on the same specific pod. So the runner would spin up 3 different chaos jobs. So that is how this entire thing works. Moving on to the types. So these are some generalized types of chaos experiment faults that you can choose from, and you can mix and match and create a generic scenario. But to be a bit more specific, you can go to hub.litmuschaos.io. This is where this is like the repository from where we pull our individual faults. So there are some categorized faults. In this case, you can see Cube, AWS, generic, VMware, Spring Boot. This is something we added new. Azure, and then there are also individual faults per se. So let's say we do memory hog, so you can see the like a generic example of how you can do it. You can see what it is, the source code, documentation, and also if you want to see the chaos engine in this case, so you can go to the sample chaos engine, you can click on edit, and you can see the exact chaos engine metadata. YAML. And the chaos experiment is nothing but the blueprint, the template that I talked about. So you can go here and you can see the template as well. So it's a pretty big template. We don't use all of this, but from the template, we extract specific stuff out. So we can use and modify according to our need in the chaos engine. So yeah, that's that. Now let's go back and check the demo. So before we move into the demo, I just wanted to quickly show you how you can install and install Litmus Chaos and go ahead with getting started with the first chaos experiment. So to start, you can go to the Litmus Chaos repository, which is nothing but Litmus Chaos/Litmus, and click into the Litmus portal directory. That is where you'll find 2 different type of ways of installation. One is the manifest mode, another is the namespace mode. So for this one, we'll go ahead with the manifest mode because we want to install a specific type of a specific version. Of course, you need to have a cluster. So in this case, we have a cluster already deployed. And you can see there's no names. These are just the basic namespace. There's no litmus or any other extra namespaces. We'll just simply go and apply whatever we copied, the kubectl apply command, and that would ensure that we have a litmus namespace created along with all the components it requires. So now if we just expand on the pods that we have in the litmus namespace, we'll see we have a few. Yeah, we have the auth front-end server and the Mongo, the database. So we'll wait for them to be up and running and healthy. Once we do that, we can go ahead and expand on the services we have, and that would ensure that we can externally access that particular front-end service. So in this case, we'll just edit the front-end service to make it a load balancer instead of a notebook. Once we do that, we'll wait for the external IP, and then we can go ahead and use that external IP to log into our portal. So once we go, we'll get this kind of a screen. The default password is admin and litmus, default credentials. So once you log in, you can go ahead and skip this set a new password. You can also do if you want to. But yeah, by default, you'll have a self agent or like a subscriber attached to it, so that the portal can identify that you have installed it, and you can install stuff in your own. You can do chaos in your own cluster. So once you do that, there are a few extra things that gets created, like the subscriber, the exporter, operator, tracker. So once all of them are running, you are basically good to go, and you'll see the agent come to active from pending. So once that is done, that means you are now ready to inject chaos in your own application. So now that we have cleared that, so this is my setup. In this case, you can see the self agent is already active. It was created today. And I have already run a drop scenario, but before I move into that, let me give you like an overview of this entire portal, how it looks like, what it currently is, where you can find what. So this is the home page. You can see the projects. If you want to do like a kind of a teaming setup where you want to inject chaos along with a bunch of team members, you can do so. You can go ahead and this is your project. If you have multiple projects, they'll show up here. You can go to the settings and you can of course invite other team members using this team menu. You can invite new members, create new members as an admin. So you can handle all kind of RBACs from this. We have a GitOps option. Right now you saw there's a Mongo that we're using. So this guy. So we use a Mongo, but if you want to change this and use Git as your single source of truth, you can opt for the GitOps mode, and then everything you do with the event tracker would be perfectly in sync because of GitOps. If you are an advanced user and want to have your own images, you can use the image registry setting. and you can add your own private custom values and your own custom image registry. So that's it for the RBAC. The next thing is the hub, which we already talked about, the default chaos hub, this one. So by default, it's embedded in your chaos center. So you have a Litmus Chaos hub by default, which has all the 57 experiments that we publicly release. But if let's say you have a custom requirement where you want your own private experiments or faults to be there, you can go ahead and connect a new hub, which can also be like a private or public repository based on whatever your choice is. And from there, you can pick the specific faults that you want. In this case, we have like all this experiment that you just saw in the public sector. So it's all the same. The next comes the delegate, which is already something we have is a subscriber. So if we come over, we can see there's a subscriber guy here, this one. So this is the agent. So what it ensures is whenever you install Litmus in your specific cluster, in this case, this is my cluster. So it just enables cluster level discovery. So let's say I have a new namespace. In this case, I have this demo app namespace. So I want to induce chaos in this specific application in this namespace demo app. So with the help of this subscriber, with the help of this chaos delegate, I can ensure that whichever namespace or whichever area in my specific cluster my application is residing, it can help figure out, discover, and target that. So that is the main responsibility of this agent. So now let's move on and do some chaos. So before I jump into showing you the chaos, so this is the application that we have deployed. This is an online boutique application by Google, by GCP. So it's a microservice demo application which you can go ahead and take a look. It's the link is Google Cloud Platform microservice demo. It's free for everybody to use. So you can go ahead and go to the release and you'll find a Kubernetes manifest. In my case, I've applied the same manifest and I've got a bunch of microservices that I can induce. I choose and induce chaos on. So this gives you like a e-commerce platform which you can go ahead and view. You can add stuff to cart. You can do all these things and it will be added to cart. So it's like a full-fledged microservice application demo that you can go ahead and use. So our aim for this demo is to actually break this product catalog microservice. So we will not be touching the other parts of it, but we'll be only breaking a specific part of it so as to ensure like what happens in the real world scenario when certain parts of your application goes down, either maybe a replica is scaled down or let's say some kind of an outage happens in one specific part of your application, but the others are fully functional and healthy. So we are going to replicate that kind of a scenario today. So what we have for in terms of the deployment is this guy, demo app. So we have ad service, card service, all these things. For this one, we'll be targeting this product catalog service. So this is the pod we are targeting. Also, Litmus comes packaged with the monitoring setup, which you can opt in if you want to like install or not. In our case, we have already installed it. So we have this dashboard, Grafana dashboard with all these pre-configured dashboards which we can use. So in that case, what I've done is added a new namespace called monitoring. Monitoring. So these are the stuff. These are the resources we have in that. We have a Prometheus, node exporter, kubeset metric, and a Grafana. So this is where I've exposed this Grafana, so that's where you can see the metrics and all from Grafana. But yeah, you can of course use this Grafana to customize and create your own dashboards to monitor accordingly. Yeah, let's go ahead and do run a chaos. So when we schedule a chaos, we will be greeted with like which chaos delegate you want to choose in case you have multiple clusters. You have like, let's say namespace deployment, 3-4 cluster deployment. So from here, you can choose which deployment you want. This is just something we get by default. That's why it's called self-agent. When you connect multiple agents, you can name them differently. You can, let's say, create an EKS agent, a GCP agent, something like that. So for this, we'll be going ahead with self-agent. We have a few options. You can import a YAML, full-fledged YAML directly. You can choose from a hub. You can clone some. You can also choose from predefined templates. For this, I'm going to keep it simple and choose from the Litmus public chaos hub, the third option. Go ahead and do next. For this, we'll do demo chaos. And everything else looks good. I'll just go ahead and do next. So here is where we do the tuning for our application. Like what this is where we tune the chaos engine. We choose the blueprint first and then we tune the chaos engine. So by default, we have nothing. It's empty slate. We just have one single like a node which says install the chaos experiment. So we'll do add a new chaos experiment, and this is where all the list of experiments faults that we had in the chaos hub will show up. So from here we can do like a pod delete, because we want to do the generic basic pod delete. Once we click on done, we get a bare minimum, like a basic list of applications, and we have no probes and stuff like that. So we want to definitely change this because it's not in our default namespace and the application label is not same. So we'll go ahead and edit this. We'll choose the namespace. In my case, it's in demo app. So we'll choose demo app. We'll also update this app label. So in our case, we want to target this product catalog service. So let's just quickly take a look at what the app label is. So if we describe this specific pod, if we describe this, we'll see the app label is up at the top somewhere. So yeah, this is the app label, app equal to product catalog service. So we'll be copying this. So this will ensure that we are targeting this specific pod and not any other thing, and restrict our blast radius. So we'll be updating this namespace to that and go next. If you want, you can add a probe. So basically you need to create like a name. We can choose from list of probes, CMD, HTTP. So in this case, let's say we do CMD, we do a start of test, end of test, edge, continuous, these different kind of modes, which you can take a look at. You can give like a specific property, run properties to it, the timeout, the interval, and you can like assert something. Let's say I want to check if google.com or something.com is accessible or not. Definitely it has to be relevant to your specific app, so you can check for the specific URL which this guy is hosted on, let's say. So I can check if this is accessible or not, and then I can just do a get criteria equal to and 200 status code. That would kind of ensure that this guy is accessible. So you can add and customize multiple probes. In this case, I'm not doing it, so we keep it simple. These are the tunables that you can update, and this would be reflecting directly to your chaos engine. Total chaos duration of 30 seconds, interval of 10 seconds each time. So these are all fine and good. These are some extra checks, some advanced configurations which you can do. But yeah, so this is done. We have updated the namespace and application labels for this. We have an option called revert schedule. This is what I was talking about when somebody asked a question about how we can, if we can revert or not. So if you enable this, it will make sure that the schedule is reverted after the completion. So all the metadata, all the extra stuff that the tool will create for you to inject, like stuff like chaos runner, the chaos operator will inject like all these multiple things. So those things, if you want to be gracefully cleaned out, you can just turn this on, and that's it. So it will just clean all the extra metadata that was created as a part of chaos. So yeah, with that, we seem pretty good as of now. And then we click on next. We can assign a weightage or like a priority if you had multiple faults, let's say a pod delete, pod CPU hog, node memory hog. So you can assign that this guy is not very important, so I can give a 2. That is very important, I can give a 10. For this, we have just 1, so it doesn't matter that much. So we'll just keep it 10. You can choose the mode of schedule, like scheduling an experiment. You can make it a cron if you want to. For now, I'm just going to do a single run and next. And this is the final step where you see like a summary of the entire scheduling that you have done. So you can see what tests you have added, the is it a cron or not, what was the description, the delegate you're doing this chaos on, stuff like that. You can also choose to view a read-only YAML. But yeah, seems pretty good to me. And now we're just going to do finish. So once you do finish, it would be scheduled successfully. And there are 2 tabs. The scenario is like the uh, parent node. The runs are more of like individual runs of that. So where this is helpful is if you have a cron scenario. So cron's parent would be the chaos scenario. The multiple cron jobs would be the scenario runs, so that it's easier for you to understand. If we click on this now, we can see our parent is running and it's doing the first step, which is the install chaos experiment. Once that is done, it will move on to the pod delete or whichever chaos injection we applied. So now let's go ahead and take a look at this boutique app, and we are also going to expand on this guy, the demo app. So because we're targeting this, we would see that the age of this would kind of terminate right now after a few minutes when this guy is injected. And we can see that this catalog service will break down. So if we come back, we can see pod leader started. And we can go back and refresh. We can see this guy's breaking. And if we come back to a terminal, we can see this guy just restarted because you can see the timer, the age is 11 seconds, whereas for the rest it's 9 hours. So yeah, this guy is in a container creating state again because we did 10 seconds as the interval and 30 seconds as the total thing. So this just restarted, and you can see at the background that this application failed, and it failed because something was not right. And it gives this application has handled it correctly. So you can see that it's not breaking the entire portal. It still has a few things like the cards and stuff. It could have done better. It still has the footer, but yeah, it's kind of like you need to organize your application in such a way that when it breaks, you can gracefully handle this instead of like going blank. So it's just throwing in a backend. Golang error at this point. So yeah, it's not really something good for the users to see. So of course you need to update and handle this way better. But yeah, this is just an application I tried out from the net, and this is the error code that is giving me. So you can take a look at this and you can figure out what went wrong. Something like a pod delete or this kind of thing happens. How can I handle it more gracefully in my application? And now for the injection, we can see that this guy is up and running again. And if I go back to my center, I can see this guy is still finishing up all the metadata. And if I go back to the Litmus, you can see a bunch of stuff is created. Demo chaos, a runner was also created, stuff like that. So yeah, these two are also created. These are the pod delete jobs, and these are the demo chaos runners. So once, because you have done a revert schedule, a revert chaos of true, once this guy finishes at the background, you can see this guy still running. It will automatically gracefully clean up all this stuff. You can just wait for it to finish. While that is happening, I can go ahead and refresh this, and this should be back to normal because my chaos injection at this point, the pod delete injection at this point is finished. It is now trying to do the revert chaos. So that's why the application is back to normal. And we can go back. I can see the pod delete things were cleared up. We'll just wait for this to be cleared up, and yeah, there you go. Everything is back to normal like it was before. So we we had only these resources before. It added a bunch of stuff, but because we had the reverse schedule enabled, it also did that and cleaned up all the extra metadata. So now let's say your application injection, chaos injection, everything is finished, and you want to check the metadata and result and verdict. So to do that, you can go ahead and click on chaos result. Logs are not available right now. It would have been if I hadn't done revert chaos because it deletes the pods which hold the logs as well. So that's why the logs are unavailable. But when it's injecting chaos, you can go ahead and view the logs if you want to. But if we come over to the chaos result, we can see, remove this, we can see that we have a giant list of metadata, the labels which it targeted, managed fields, and like it's like the entire dump of what happened. You can see the status as well. You can see the verdict, probe, did the probe passed or not, and failed step. Because there is no failure in this case, so failed step is NA. If there was a failure, so you'd get like a detailed explanation, a summary of what failed, where what exactly failed. In this case, our application did not fail. The chaos injection did not fail. The chaos injection was correct, but the application which we targeted did not handle it very gracefully. That's why the application failed. That's why you're not getting a fail step. But if let's say there was a problem in injection, something was not right and stuff like that, so you'd get a detailed summary in the fail step itself. So yeah, that's an overview of this entire portal in short. You can go crazy with it and do multiple stuff accordingly. You can also schedule a bunch of faults together and like create a very um, like an awesome scenario, and then you can plan your game days according to that and have like specific days where you do this kind of planned outage so that your systems are more and more resilient by the day. So yeah, that's the demo from my end. I'll go back to my slides and talk about what's next for Litmus. So the future roadmap, what we do plan to have is, of course, an increased community support because like our future roadmap is kind of aligned based on what the community wants us to do. In our case, we are also introducing something like Litmus 3.0, which is in beta right now. This is what I just showed you is Litmus 2.14. And after that, we moved on to Litmus 3.0, which is open to the community for everybody to try. It's like a entire new portal with a lot of new features that we are planning to introduce. So this entire thing was part of a community effort and based on the feedback that we received from the community. Other things that we are trying is like increase support for non-Kubernetes infra components. Right now we have non-Kubernetes support, but they are not as fast as the other support we have for Kubernetes entities right now. So we are looking forward to introduce and increase that area. We want to improve the SDK to create like a very robust set of user-defined experiments. Right now, you can go ahead and create like chain and create multiple experiments from the SDK using your own knowledge, but it also ensures that you are well versed with the SDK. So we are planning to smoothen down the process a bit. We want to introduce additional probe types. Right now we have four: the HTTP CMD, Prometheus, and Grafana. The HTTP Prometheus, Kubernetes, and Grafana. So we want to increase that and introduce more probe types in the future, and of course improve observability. So right now we have connections with Grafana, Prometheus for observability, but we want to also embed these kind of things in the platform so that everybody gets like a same page view of everything, so they don't have to context switch and go to Grafana and Prometheus and check all this stuff. So yeah, that's the future roadmap, which of course is we are planning and taking more and more feedback and improvements in the community. So as a community member, how can you contribute and get into this entire project? It's not just like there's not one repository which you can contribute to, but the entire Litmus Chaos organization is split up into multiple smaller utilities and things which you can choose. So there is stuff for front-end developers, for DevOps people, for back-end folks. So in terms of whatever you want to contribute, development, bug fixes, documentation, feature reports, etc., you can do that. If you're interested more in the hub side of things, the faults, the experiments, you want to add more faults to the public chaos hub, you can go to the chaos charts repository and take a look around. That you'll be involved in more of a Helm and more of a YAML formation, that kind of contribution. If you are more into Golang and backend side of things, you can check out the chaos workflows or the test tools. The test tools would involve things like creating a weak and a resilient manifest for yourself, involving yourself in load testing, locus, tools like that. If you're into UI, you can check out Litmus UI and the website Litmus Chaos, which is the Litmus website. Litmus UI is more of a design system, a design library that we have, which we use for our internal components. And Litmus Go is nothing but the SDK, which is again a Golang repository. So you can go ahead and check, improve and check things like that if you are more into backend. So yeah, that's the entire gist of how you can contribute. And now for if you want to get involved, here are some of the links that you can choose. You can see and go ahead and explore. You can see our YouTube, Twitter, Slack documentation as well as the main code repository. Yeah, thanks. That's all from my end.
Yeah, thank you, Sayan. This is like really, really helpful. I will let other people to ask any. Do anyone has any question? Please raise your hand or unmute yourself. Okay, then I will ask you a question, Sam. So if anyone wants to write his own custom test, Litmus test, so right now I think it's only supported Kubernetes, so that means we need to write in Go, or we need to create our own CRD operator, need to insert into a cluster, or how it's going to work.
So if you want to write your own, let's say fault, so you can use the Litmus SDK. So with that, it would kind of bootstrap your entire. It will give you a head start and give you a bootstrap template of the entire YAML, and from there you can customize and add your own bits and pieces to it. So let's say the blueprint, right, the chaos experiment. So it would bootstrap parts of the chaos experiment for you, and then you can add pieces to it in the YAML. If you're not comfortable with that, because that's like a more of a CLI SDK, that kind of an approach, you can go ahead and let's clone one of the experiments faults, let's say bot delete, and then you can modify that and customize it in the YAML itself. So once you do that, you can create like this entire private chaos charts repository. For now, we have a public charts repository, which is the Litmus Hub, Chaos Hub. So you can clone that and you can modify experiments or faults in that and add it to your Chaos Center. So that way you have access to your own private repositories, and the portal will pick certain experiments that you choose from there. So you can either go via the YAML route if you're an advanced user. You can go ahead and modify the YAML directly by cloning Chaos Hub, or you can go the Litmus SDK route where you can use the CLI to add stuff and generate this entire metadata YAML thing for you.
Okay. Okay. The second question is, in production environment, how someone introduces chaos. I mean, I think the way you have shown it, people should not have do it in production environment. So this should be the entire process automated. So how people are doing it in production environment? That's the question.
So sure, got it.
Yeah, sorry, go ahead.
So so in production, there are like you'd not definitely you'd not directly run this in production because it's a bit of a risk. So we do encourage people to do it, but of course, like I like to think of it in this viewpoint. Production is something which is already stable, right? So you have three environments to this one. I would call a staging, QA, and then a prod. And what I like to do is I like to create a clone of the prod deployment somewhere, the production setup, exact clone of production setup, and then use it because the production is obviously stable. Use that stable clone to inject chaos in that, and then you can automate this in the form of, let's say, a CI pipeline or something. So whenever you run a deployment in the production, in the cloned version of production, you always get the validity or reliability validation that this guy is running perfectly in my clone system, so that I can easily induce that specific setup in my production as well. But if you're not confident, you can go ahead in the QA and then you can do game days there. So once you do game days, you'll find faults. You'd be getting feedback. You'd be polishing that, and once you are okay with the game day setup in the QA, you can move that in the pipeline for the clone production. So that way you have a stable build for the clone production, and then you can copy that for production. So wherever you are breaking stuff is actually QA, but because you have an entire validation, an entire suite where you're doing this game day test and everything, which is polishing this every single day, you can take that in the clone version and then to the main prod. So that way you have like a smoother pipeline flow in prod.
Yeah, so that part is fine, but how to automate this process? Or this is just a YAML file, which is similar to what we are doing with Kubernetes, like using the Argo CD or something else. We can automate this entire process, or how can we automate it?
Yeah, you can automate this in the sense like wherever you deploy to production in the pipeline, you can add stuff in the CI pipeline itself, so that way whenever you deploy to prod, the chaos injection, the chaos experiment, all this suite is already happening. If not, let's say if you don't want to put it in the pipeline, then I wouldn't say you would necessarily want to automate this, but you would rather want to run game days. So that way you can specifically before deploying to prod or before release, you can run a set of game days and then do this kind of specific testing based on your user base, so that you can also customize and modify this target chaos injection differently. So let's say sometimes you want to not do a pod latency and a black hole testing. So those kind of change in scenario would help and assist when you're doing game days. So I wouldn't say you can automate a game day as of such. Right now with Litmus 3.0, we have this capability of automating a game day as well. So we are introducing this concept of a game day where you can create a game day as like a cron. So that way whenever you have your prod deployment, before that you can give the timer of the cron and the game day would automatically run itself. But that's more of like a uh, you can edit it ultimately, but that's like you have defined a set of game day and it's running again and again, right? So what I suggest is you can have that as a safety net, but modify the game day based on your preferences, so that based on whichever customer is seeing whatever problems, you can update the faults and change it into a black hole testing or a pod latency testing or a node memory hop testing or whatever you want. But yeah, you can automate the game day and that would help in the flow, or you can add it to CI. These are both things.
Okay, sure. We still have 4 minutes, so I will quickly ask a few more questions. And if anyone else has any question, please raise your hand or just unmute yourself. The first question is not related to Litmus Chaos, but just a general as a tool of a chaos engineering. Uh, can it is possible to bring down the entire AWS region using the Litmus Chaos, or not Litmus Chaos, but just as a chaos engineering tools as a whole? And how does it does in the backend? Like how it brings down the whole region? I mean, all the services and everything.
So we do have something called AWS kill, like instance kill, ID kill. So basically, if what happens in the backend is our backend expects like the secrets that you put because it's targeting a non-Kubernetes entity. So it expects the AWS or the GCP credentials to be there as a secret so that it can enroll itself in. So once it does that, it would find your specific ID, instance ID, and once it finds that let's say instance label or ID, let's say if you do it via label, if you have that same label attached to multiple instances, it will bring down all the instance together. And if you want some specific ID, it can bring that specific ID, that specific instance down. But let's say you, for your use case, if you label that entire all the instances in that region as let's say something region abcd, and if you target that region abcd with that aws instance kill of the with the label mode, then it will eventually bring down all the instances in your region. So yeah, it's a pretty extensive injection. So in that sense, everything would be down, and all it requires is basically your secret, the IAM secret that you are storing in your cluster itself. So once you are done with that, you can also remove that secret. But yeah, once the injection is happening, you would need to attach a reference of that secret in your YAML so that it understands that this is the specific region and this is the specific account I'm supposed to target. And then once it figures that out using chaos operator, it would bring down all the instances by label in that particular region. So that's how you can achieve something like that.
Okay, got it. Okay, a few more questions, but just one last question, which someone asked. Based on your experience, if like if you want to improve one thing in the chaos engineering, or you have performed the chaos engineering experiment and you find it out, okay, later down the lane that you can improve something in it, what is the one thing you want to improve?
Prithvi, would you want to take that?
I think there are many things you can improve, but I think the way chaos engineering is measured and verified, I think one thing can be improved. Usually, we have seen that chaos engineering success is identified through, I mean, metrics that are used by SREs like MTTR, MTTF, MTBF, and all this. But I think all the chaos engineering tools out there, I think the focus should shift to identifying resilience scores and resilience percentages, where you are actually calculating it in the sense that I mean, how many steady state checks were successful, how many, I mean, chaos tests were run against the number of chaos tests possible, and what was the success percentage. I think this is one thing that can be improved moving ahead. And then other than that, I think what I'm looking forward from chaos engineering is the increment of test suits. I think we are still understanding more in terms of failures that can be created and failures that are possible out there. So I think these two things are especially something I feel can be improved. But yeah, other than that, if you talk about chaos engineering itself, there are probes, and then there's obviously creating our own experiments in terms of, you know, we are doing it. I mean, writing YAML files or enabling it by tuning the YAML files. But there's so much more you can do in terms of it in terms of integration, as well as creating our own experiments. If I just speak from a community aspect.
Okay.
Yeah. One thing I'd also like to add is the currently in the chaos engineering market, the adoption market, it's earlier it was not being adopted a lot. Currently, the condition is the state is like it's been adopted but not used as much. So multiple challenges that people are reporting are is like basically the fact of being very difficult to use, or like multiple integrations already in place. So we don't really know how to get started with it, stuff like that. So what I would want to see like moving forward is this thing being very not integrated per se with a bunch of tools, or like rather than have like a plugin system where if you want you take it or you don't, and make it very bare minimum so that things are very easy for day zero user. So you should still be able to do what you want to do, but not have a bunch of integrations pre-packaged, so that people don't get confused in the long run. So yeah, make it very minimalistic, but also make sure that it has quality. And then whichever things you want, you can induce as like in a plugin system. Yeah.
Okay. I know we are 2 minutes over time. Just one last question. This has been asked by many people. So, except Litmus Chaos, any other chaos engineering tool which you guys can recommend?
As I said, there are a lot of tools out there. So if people are looking for open source, then they can get started with Chaos Mesh, Chaos Toolkit, Chaos Blade, Chaos Monkey. Yeah, these are the open source options. And if they are looking from an enterprise perspective, then there's Harness Chaos Engineering, Gremlin, SteadyBit. I mean, I think the free versions also help them get started. So yeah, I think these are the very popular tools out there. And then there's obviously Azure Chaos Studio. There's I think AWS FIS. So yeah, if I mean there are so many tools out there, but yeah, I just mentioned a few popular ones which people can get started with.
Okay, sure. Yeah. Thank you so much, Prithvi and Sayan, for your time. I mean, I personally learned a lot out of this in the last 1 hour, and I'm definitely give it a try. But thank you guys for your time and sharing your knowledge with the community. Yeah. Thank you so much again.